Hello, pre-algebra scholars, and welcome to lesson 22, session 3. This is on page 525. Our objective here is I can perform operations with numbers expressed in scientific notation, including adding, subtracting. That's what we're going to look at today. And then next session we'll look at multiplying, dividing, okay? So basically, I can add and subtract things that are written in scientific notation. Let's take a look. And that's a cool picture, I think. The 48 congeus states, meaning the 48 states that are together, have an area of about 3.12 times 10 to the 6th power miles squared. The area of Alaska is about 6.63 times 10 to the 5th power miles squared. We didn't need this picture to tell us that Alaska was smaller, right? Because of this 5 is smaller than this 6. Okay. How many fewer miles? How many fewer? How many fewer miles in the how many fewer square miles in area is Alaska? Write your answer using scientific notation. Okay, check this out. I think that this means fewer means to subtract. We're always looking for those key words to subtract. Okay, so I need to take this big one, this big area, and subtract Alaska from it. Okay, we can do this. Well, so this is going to be 3.212 times 10 to the 6th power minus 6.63 times 10 to the 5th power. I just realized, how are we going to do this? I don't know. Well, I'm going to show you two methods that hopefully you will latch on to one. And you say, that works for me. I'm going to be honest. This first method is the lazy method. And I have a feeling it's the one most of you are going to prefer. Because this first method is just going to have you rewrite these in standard form. And then subtract knowing like how you've always done it, okay? How you've always subtracted numbers. We're going to make this into a 3rd grade problem, 4th grade problem. I don't know. Whenever you learned how to do subtracting multi-digit numbers from one another, okay? So we are going to turn this into an elementary school problem. Let's do it. So you already know if I've got 3.12 that I need to move this 6 times, right? 6 times, so let's do it. 1, 2, 3, 4, 5, 6, decimal point, 0, 0, 0, 0. Okay, there's my first number. I'm going to rewrite this so we can see it better. This is 3, 1, 2, 0, 0, 0, 0, comma, comma, 3,120,000. Okay, that makes sense. Now I'm going to do this one, 6.63. Move that decimal 1, 2, 3, 4, 5. Fill in my gaps. 3 gaps. Okay, now I'm going to bring it over. Here's the important thing. Line up your 1s and your 10s and your 100s, okay? Line up right to left. You already knew that. You just maybe forgot. So I want to remind you, okay? When you subtract or add numbers, you've got to line up the place values. Okay, so 0 goes here. 0, 0. Okay, we have 3 zeros, and then a 3, and a 6, and a 6. Do you see how I perfectly lined this stuff up? Okay, my 1s are here, my 10s are here, my 100s are here, thousands, 10,000s, 100,000s. Okay. I should say method, and if you don't have room to write this, just write it somewhere else. Method 1, write in standard form. Okay? Write in standard form. This is our first way of doing this. We're going to write it in standard form. Okay, we've got our subtraction problem now. We knew this is subtraction. So now that we've rewritten these in standard form, we can subtract. 0 minus 0 is 0. 0 minus 0 is 0. 0 minus 0 is 0. 0 minus 3, I can't do that, so I'm going to borrow from this 2. I'm going to take 1 away from it. 10 minus 3 is 7. Ooh, 1 minus 6, I can't do it, so I'm going to borrow. 11 minus 6 is 5. Ooh, 0 minus 6, I can't do it, so I'm going to borrow. 10 minus 6 is 4. And a 2 left over. Boom, boom. There's our answer, right? And we need to rewrite this in scientific notation as well, but let's start rewriting this. Let's say this. Alaska has 2,457,000, or let's write it in scientific notation. 2, a decimal goes right after that 2. 0.457 times 10 to the, we moved it 1, 2, 3, 4, 5, 6 times. Alaska has 2.457 times 10 to the 6 fewer miles squared, or square miles, than, oh my goodness, than the lower 48. That's how I hear it, not the contiguous states. Well, I've always called them the lower 48. So, okay, that's method 1. Our book gives us a method 2, though. Our book says, hey, my friends, like, you know that you can do everything you want to in scientific notation. You don't have to jump back and forth like Mr. Gibbs just showed you. Like, I don't know why he would show you that. The book is upset, and I understand, okay? So they are going to show us how we can rewrite both of these numbers to give us the same power, because we need them, just like we did over here, we need them to line up in order to do this subtraction, okay? So if we don't have our numbers lined up, then we can't do the math. So what did they do? They took this number here and they said, let's write it with a power of 5. Well, how do we do that? This number decreases every time we move the decimal one spot to the right, okay? And they moved their decimal one spot to the right. When they did that, this became a 5. And now they've got this, 31.2 times 10 to the 5th minus 6.63 times 10 to the 5th. When these are the same power, it's really, really, really easy to subtract in scientific notation, okay? Because all you need to do is subtract these front numbers, okay? They did this minus this, and it's going to stay times 10 to the 5th. That's going to stay the same. Notice it stayed the same over here, right? We started with 10 to the 6th. We ended with 10 to the 6th. Okay. So all we need to do is 31.2 minus 6.63. And it's going to look like really similar to what we did on the last page, right? We got to line up our decimal point. We're going to borrow. We get a 7. We're going to borrow. We get a 5. We're going to borrow. We get a 4. And a 2. But our decimal point's right here in the wrong spot. Times 10 to the 5th power. What do we have to do? We have to move our decimal 1 to the left. And that's going to increase this exponent, and we get 2.457 times 10 to the 6th power. Exactly what we got over here. Okay. The other way we can do it is, we notice we've got to make these powers the same. We could increase this one by moving this to the left. Whenever we move our decimal to the left, we increase that exponent. So they did that, and they got a 6 now. Now these are the same exponents, and same thing. You can do 3.12 minus 663. Boop. Borrow, I get a 7. Borrow, I get a 5. Borrow, I get a 4. Bring my decimal point down. There's a 2 left. Times 10 to the 6th. And we don't need to rewrite from there. I'm so sorry. That was off the page, or off the screen. We don't need to rewrite from there because that is correct scientific notation. Okay? So you've got to pick a way that works for you. Okay, let's think about this just a little bit more. Let's think about this just a little bit more. Okay, so it says, okay, we did this. We did this. Why does the second step require one fewer step to complete the solution? Well, it's because we ended up with correct scientific notation. We ended up with correct scientific notation. You see this? That's what they're talking about right here. If we move the smaller one this way to the left and make it match on the bigger exponent, it's usually going to come out with one fewer step for us. Suppose you want to know the sums of the area. You want to add the areas using a similar method. Write your answer in scientific notations. Do the methods also work for addition? Okay, we can do that. So instead, let's use this. We're just going to borrow this idea, but we're going to do addition instead. So I'm going to write right here. Where do we want to write this? They didn't really give us room. We'll write it right here. We're going to do 3.12 times 10 to the 6th plus 0.663 times 10 to the 6th power. Okay, we're jumping a step, right? We're jumping a step. We've already rewritten these. Okay? And we're going to do exactly what they did. They said take this 3.12 plus 663. So we're adding the areas this time, and it's still going to be times 10 to the 6th power. So if I add these together, 3.12 plus 0.663, this is a 3, an 8. I put a 0 here to help you see that. 1 plus 6 is 7, and 3. Okay, so this is 3.783 times 10 to the 6th power. Does it work? Absolutely. We just have to make sure that this power is the same, and that is exactly what this next problem is. What must be true about the numbers written in scientific notation before you can add or subtract? The powers must be the same. Explanation point. Most important idea right here. Okay? If you are going to add or subtract in scientific notation without converting it into standard form, you have to make sure the powers are the same, because that power is going to stick with you, okay? We're not moving a whole bunch of place values when we add or subtract. The powers must be the same, and they'll stay the same. When you get into the practice next, you'll notice that some of them are already the same. When that happens, this is really, really easy. The only difficult time is when they are not the same, and then you need to change it around or write it in standard form. So I gave you 2.5 different strategies for doing this. I gave you method 1, writing it in standard form. Method 2, getting it into, getting these exponents to be the same so you can add or subtract the numbers out front. And you can either move the first number or the second number, but these exponents have to be the same either way. Then you can just add or subtract those numbers out front. So which method do you think is going to work best for you? I want you to real quick jot down what you think. And you can get on to the practice now. Thank you.